So wave motion basics. So a wave is a disturbance that propagates through a medium. That means basically it moves through a medium. Most important misconception about waves. Waves transfer energy, not matter. Usually when we think of waves, what do we think of?
Ocean.
The ocean, the beach. When you're playing in the waves at the beach, the waves knock you over, the waves are crashing against the shore. That's different than the types of waves we're talking about. If we're looking at basically any other type of wave, and you'll see some of them later on, the actual particles, like the water that's in the wave, or if we're looking at a spring or a slinky, those particles aren't moving very much, and they don't travel with the wave. So it's the energy of the wave that's being transferred, not the matter. Okay? Oops. So the following quantities describe a wave. You've got frequency, period, wavelength, speed, and amplitude. So frequency is the number of cycles per second. It's measured in hertz or CPS, cycles per second. Frequency of the wave is determined by the source of the wave. Now, if you look at the board here, you can see that I've drawn a wave. You might have recognized this from math class, maybe. So this is a wave that's just moving off. We can say off to the right here. If we picked a spot, let's say right here, and we, over a certain period of time, counted how many crests went by, because that's one cycle. If we go from here to here, or from here to here, that is one cycle. Does anyone know what the other term for that is? Wavelength. This is one wavelength. This is one wave, basically. So from where it starts to where it repeats. Crest is the top of the wave. And that's a trough. That's also one wavelength. Okay? It's coming in a later slide. Now, if we picked a spot, if we were just sitting right here and we counted how many wavelengths went by, let's say we had someone who could count really, really fast, and 10 crests went by in 1 second. Then the frequency of this wave would be 10 cycles per second, or 10 hertz is another way to write it. So can I get someone to come up here real quick? Helen, thank you, Helen. Hurry up, we're recording. So here, Helen, hold that. Okay, so we've got a spring here. Now, all you have to do is hold it, okay, you ready? So you girls count how many crests go by. So I'm going to just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was 10 cycles. 12? So that would be an example of how a wave would travel through a medium. The medium here is the slinky. And I sent it down, and every time I sent a pulse down, that's one cycle. So period, capital T, this is the time for one cycle. It is measured in seconds, and it's the inverse of frequency. Students often will get these two confused. So if frequency is how many times, how many crests or how many cycles go by each second, then period is, well, how long does it take for one? So how long does it take for one cycle to go by, or how long does it take for one wavelength or one crest to go by? So if we look at the example on the board here again, oops. The example on the board, we had a frequency of 10 hertz. So every second, 10 waves go by. So how long does it take for one wave to go by? A tenth of a second, 0.1. And that's why its period is the inverse of frequency. That's a 1. So the speed at which the wave travels through the medium. Shh. Charles, Helen. Measured in meters per second. Now, here's an important thing. The speed of the wave is determined by the medium it travels through. I want you to keep that in mind when we do a little exercise at the end of class if we have time. So wavelength. That symbol there is called lambda. And it's basically a fancy upside-down Y. So you just go like that. If you draw that, everyone will know what you're talking about. My lambdas are not very good. So wavelength, this is the length of one wave. Measured in meters, because meters is our standard unit of measurement for length. Wavelength depends on the frequency and speed of the wave.
What's amplitude?
So amplitude is the maximum displacement from rest. The amplitude varies with the amount of energy the wave carries. All right, so for amplitude, another common mistake I see is it's from rest. So if you look at our wave that we've created here, this is our resting spot. So when there's no wave, that's whatever the medium is, if it's a piece of string or a slinky or whatever, it's at rest here. So the amplitude is from rest to its maximum. So that is your amplitude there. You can also measure it that way as well. So those are both amplitudes. Oftentimes I'll see students go from the top of the crest all the way to the trough and say that's the amplitude. That is not correct. So make sure you don't do that. That's a tuning fork. So there is a relationship between frequency, velocity, and wavelength. And it's shown by this equation here. So velocity is equal to frequency times wavelength.